So we're going to go ahead now that the temperature, since it's relatively cool in our test cell, is down to 88°C, we can restart the engine. Right now, as the engine is getting restarted, we're waiting for the rail pressure to start to drop as the PID controller that's controlling duration starts to work a little bit better. You can see here now we're running with a rail pressure of about 130 bar, which is close to our, or is what the set point is. I'm actually going to turn that up a little bit to 150 bar. This particular engine, the typical ranges of fuel pressure that we run with are between 130 and 200 bar, so we're going to stay a little bit more inside that range rather than at one edge of it. I'm also going to enable my coolant control PID controller to that thermostat so that we don't overheat the engine and have it stop on us again. So we're just going to let the engine sit in idle for a couple of seconds until we see that the coolant temperature starts to decrease, and then we can start adding a little bit more load to it. I might actually turn open the throttle a little bit to increase the engine speed some without really trying to load it down a whole lot to increase my coolant flow. Although that seems to be causing the engine to warm up even more quickly. So we'll kind of hunt around and see if we can find a point for it to start. So what I'm doing is I'm adjusting the PID settings on the engine. Basically, the way that this particular PID controller is set up is it has a minimum and a maximum command, and I wasn't able to open that valve at all because I was basically driving my output, or my actuator was saturating, and so by opening that up, I was able to more or less command a change in that value. And now I've cooled the engine off and we're able to continue with our testing. So we'll bring the detailed PV diagram back up. Hide these faults since they're not really a problem for us anymore. And you can hear the engine start to load down as the dynamometer controller opens the load valve on the water brake dyno. Another thing I'm going to do is I notice that my air-fuel ratio, or my lambda value, is a little bit rich. There, I guess it's back to stoichiometric, so I'm not going to need to adjust that controller at this time. But we do have the ability to come in and basically change our lambda controller so it's got different PID mins and maxes. Again, right now we're actually running this as a PI controller. Our time constant for the derivative is set to 0. We've got a single pulse that we're doing about 0.3 or so milliseconds. So we're going to actually increase the throttle position. get back to that other operating condition we were running at previously.